Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's biweekly contest, minimize the maximum of two arrays. Uh, as per my understanding, this problem is more interesting than the last problem of the same contest, count anagrams. And as of me recording this video, the number of submissions are also much greater for count anagrams. So, anyways, let's move ahead. The problem states that you are given two array 1, array 2, which are initially empty. You need to fill them with positive integers, right? And you have to fill both of them in such a way that these conditions are satisfied. What are the condition? The condition are array 1 contain unique count 1 distinct positive integers, right? And each of these integers should not be divisible by divisor 1. Similarly, array 2 contains these many number of distinct integers, and each of those integers should not be divisible by divisor 2. And there is no integers which is common between array 1 and array 2. Okay, now you are given these four integers: divisor 1, divisor 2, unique count 1, unique count 2. Now you need to fill array 1 and array 2. Now after filling both the array, you need to find out the maximum integer between these two array. Okay, now once you find out the maximum integer between these two array, that will be the, so first of all, there can be many possible configurations, right, to fill this entire thing. Now let's say you fill array 1 and array 2 in one way, and you find out the maximum value of that arrangement. Now there can be many possible arrangement, right? So among all such arrangements, you need to find out the one which have the minimum value. Okay, so let's take an example. Let's say divisor 1 is 2, divisor 2 is 7, unique count 1 is 1, unique count 2 is 3. So what does it mean? The first array should contain one distinct element. Second array should contain three distinct elements. All the element of the first array should not be divisible by 2. All the element of the second array should not be divisible by 7. Okay. Now they are saying that one such possible configuration is this: array 1 has 1, array 2 has 2, 3, 4. Now you can see this satisfies all these three conditions. First of all, there is no integer which is common between array 1 and array 2, right? Second, all the integer of array 1 is not divisible by 2, and there is one unique element, one distinct element in array 1. Similarly, for array 2, all the elements here are not divisible by 7, and there are exactly three unique numbers in the array 2. So all the conditions are satisfied. So this is a valid arrangement. Now, for this arrangement, what is the value? The value would be the maximum of all the values of array 1 and array 2. So what is the maximum? Maximum is 4. So the value of this particular arrangement, where array 1 is 1, array 2 is 2, 3, 4, is 4, right? Now you can try any other possible arrangement, and you will see, of all the arrangements, you will not be able to form one configuration where the the maximum value of the of both the array is smaller than 4. Hence the output is 4. Okay, so hope the problem statement is clear. Now how to solve it? So focus, like, let's start with beginning. Okay, so let's forget about all these scenarios, and let's start with the what we need to let's focus on what we need to return. We need to return the minimum possible maximum integer that can be present in either array. Okay, so in a way we need to find the minimum integer value. Okay, so let's say we need to fill array 1 and array 2, right? And these conditions should be satisfied, right? Now we need to find out the minimum possible integer, right? So what is the minimum possible integer? Minimum possible integer could be 1, right? So what we can do is, or what we can try is, can we fill array 1 and array 2 such that minimum possible integer is 1, and uh, these all conditions are satisfied. Okay, so can we do this? Can we fill array 1 and array 2 such that the maximum value across array 1 and array 2 is 1. They both have unique element, distinct elements. Array 1 is not divisible by div 1, array 2 is not divisible by div 2, and so on. Like all these conditions satisfied. Now let's say we say, okay, we can't do this. Right? Let's say you have some way in which you are saying that okay, you can't do this. Then you will try to, right? Okay, can I make, or can I fill array 1 and array 2 such that it satisfies all the condition and the maximum value across these two arrays are 2? Is it possible? If the answer is no, then you will try 3, right? And so on and so forth, right? So the first integer where you get, okay, I can satisfy all this condition and I can fill array 1 and array 2 such that the maximum value across this array is x, then x is my answer. So that's what we are looking for. Okay, so we need to, again, just to reiterate, we need to find the minimum possible integer, right? So minimum possible integer is 1, right? So you'll start with 1 and see, okay, can I fill this, can I fill array 1 and array 2 such that the maximum value across these two is 1 and it satisfies all this condition. So that's what we need to answer now. If we are able to answer this correctly, we have solved the problem, right? So what we need to answer, given x, find me whether it is possible to fill array 1 and array 2 such that the maximum value across array 1 and array 2 is x and it satisfy all this condition. Okay, so that's what we need to now focus on. So the problem statement is now reduced to, given a x, find me whether it is possible, whether x can be answer or not. That's it, right? So now how to solve this? So let's see. Uh, we need to find out, let's for the purpose of this example, let's say given x is 17, right? So we need to fill the array, uh, fill these two array such that the maximum value across these two arrays is 17 and it satisfies all these conditions, right? Now first thing, what exactly these conditions are? This condition says that okay, array 1, any element of array 1 should not be equals to any element of array 2. So we need to fill both of them in distinct value. So that's okay. Now array 1 should not be divisible by divisor 1. So this means that, so we have 17 elements, right? And it says that array 1, any element of array 1 should not be divisible by div 1, right? So let's just draw a circle, right? Let's draw out the sample space. We have done set theory in our mathematics, so let's just do that. So let's say this is our sample space. So this contains all these 17 integers, this big circle, right? Now, as per the first condition, it says that array 1 should not be divisible by div 1. Okay, so let's say this. So what, like, so there will be some integers which which are divisible by div 1. So what are the possible, possible values of, or what are the possible good values of array 1? So let's say there are some integers which are divisible by div 1. So for the purpose of this example, let's say div 1 is 2, okay, and div 2 is 3. Okay, so now let's say there will be some integers which are divisible by div 1, right, among these 17 integers. So let's just denote that by this small circle. So this small circle denotes that uh, the integers here are divisible by div 1. So for example, this circle will contain 2, 4, 6, and so on, right? So now there will be integers which are divisible by div 2 as well, right? So let's just build a circle for them as well, right? Now I made this circle intersect. Now why I made this circle intersect? The reason is there will be integers which are divisible by both div 1 and div 2, right? So for all these integers, like this area denotes all that integer, right? So first of all, this big circle denotes the integers which can, integers like 3, 6, 9, and so on, right? But there will be integers like sorry, 3, 9, and so on, but there will be integers like 6 which is divisible by both 2 and 3. So 6 would lie here. Similarly, there will be integers like 12. So 12 would lie here, right? So that's what this circle denotes, like this intersected area denote. Now let's think about it. Will this intersected area, so will this blue area, current blue area, can present in any of array 1 and array 2? The answer is no. Like this blue area can't be present in array 1 or array 2, right? So that is clear. Now let's talk about the left part. So this one was the one which are divisible by div 1, right? And these are the ones which are divisible by div 2. So now can this part, so first of then okay, first thing is anything outside this boundary, like anything outside this boundary, this blue boundary, anything here can be assigned to both array 1 or array 2, right? There is no restriction on that. That is clear. But what are the restriction? Restriction is anything which lies here, like in this part of the circle, anything which lies here can be assigned to array 2 only. Okay. Similarly, anything which are part of this circle, this boundary, will be assigned to array 1 only. Okay, so again I'm repeating, this area denotes everything which are divisible by d1 or divisor 1. So this can't belong to array 1, but they can happily go to array 2, right? Because there is no restriction in that. Similarly, this area or this circle denotes the one which are divisible by d2. So this can't go to array 2, but they can happily go to array 1, right? So what we are saying is there are some integers which can go to array 2 only. There are some integers which can go to array 1 only, and there are some integers, right, which can go to both array 1 and array 2. Now you need to fill array 1 with cnt1 number of integers and array 2 with cnt2 number of integers, right? So again, like we will look at distinct afterwards, like, or maybe this can be an exercise for you, but we can completely ignore this distinct. Okay, so you can think about it. We can completely ignore this distinct at all, like completely. So now what is the problem? Now the problem is there are some integers which can go to array 1 only, there are some integers which can go to array 2 only, and there are some integers which can go to both array 1 and array 2. Now tell me whether, given this configuration, whether it is possible to have cnt1 number of elements in array 1 and cnt2 number of elements in array 2. Is it possible or not? That's the problem. Okay, now how exactly, let's just take an example. Okay, so let's say there are okay, so let's just take an example. Let's say there are 7 integers here. Okay, and there are 9 integers here, and there are 5 integers outside, right? So now you need to find out cnt1 is 10. Okay, and cnt2 is uh, again 10. Okay, so now you have to fill cnt1 with 10, array 1 with 10 distinct integers, right? You have to fill here 10 distinct integers. Now what you are saying is these 5 integers can go in both array 1 and array 2, right? But these 9 integers can go only in array 2, and similarly these 7 integers can go only in array 1, right? So how exactly will you make this configuration? How exactly will you make this configuration? So notice that because there are like you will try to put the numbers which have restrictions first, right? So what you will do, you will, okay, I need to assign 10 integers here, right? So let me just put this 7 integers here first. I will fill the 7 integers here because these 7 integers will be the one which can't belong to array 2. Okay, so let me just put 7 integers here. So once I put 7 integers here, how many integers, like how many thing I need to fill yet is 3, right? We have filled 7 integers because these 7 integers are the one which are which can't belong to array 2. So that's why we filled it in array 1. Now similarly, there we have to fill 10 integers here, right? So there are 9 integers already which can be filled here. Okay, so you will try to fill those 9 integers first, and then you will be left with one integer. So now you have 5 integers which can belong to either of these, right? So now you will start filling up. Okay, now how many integers are left? There are 3 integers here and there is one integer here, right? So total 4 4 distinct integers are required and we have 5. So just assign any one of them here and you will be good, right? So hope this makes sense. So what we are doing is we have this like we have tried with sample space, like we have tried with x equals to 17, and we draw a circle which says, okay, this is my sample space of 17 integers. Now among the 17 integers there will be some integers which are divisible by d1, there will be some set of integers which are divisible by d2, and there will be some integers which are divisible by both. Okay, so now the one which are divisible by both, I can't do much with it because they can't be present in array 1 or array 2, right? So I can't do much here. But for the one which are only divisible by d1 and not d2 are the ones that can be assigned to array 2, right? Because array 2 has the restriction for the integers which are divisible by d2. It doesn't have the restrictions for the integers which are divisible by d1, right? So these 9 integers can be something which can be assigned to array 2. Similarly, there are these 7 integers which are divisible by d2 but not with d1, and they can belong to array 1. Notice that this 7 can't go to array 2 and this 9 can't go to array 1, right? Now, given this configuration, we need to just answer, okay, can I fill array 1 with 10 distinct integers and can I fill array 2 with 10 distinct integers? So, how exactly we will start filling? We will start filling by first placing these 7 integers here, because if we start with this 5, let's say we start with this 5, we put these 5 integers here, right? And now we are left with 5 more. So, we take 5 more from here. So after this configuration, we put 5. Okay, let's just change the colors. So we put 5 here, this 5 here, and then we put from here we took, so from here we took 5, and from here we took 5, and we fill this 10 integers from in array 1. Now for array 2, we can't take anything from here because like what are the possible value, like what are the possible candidates for array 2? Everything which is outside, like among these 5 integers, these 5 are already assigned, we can't do much. We can only assign these 9 integers here, right? And we'll see that, okay, we are done. So there is a there is a better solution. Basically, instead of blindly assigning these 5 integers are the key, they can belong to anyone, right? So let's just first assign the ones which can belongs to only one of these, and after that, for the remaining I will use this 5 integers. Okay, so hope this makes sense. So that's what we are doing. So the pseudo code would look something like this. So we have to find out whether it is possible to uh, arrange this element such that all this condition is satisfied and the maximum across array 1 and array 2 is x. So that's what we is possible function is. Okay, so now here, as we discussed, we will just find out, we have to find out these three places. First is this part which says the integers which are divisible by d1 but not by d2. Similarly, this part, integers which are divisible by d2 but not by d1. Okay, so that's what we have found. We found out first the one which are divisible by both, right? uh, we like, okay, so this function, this x by LCM, is something we will look at, but we found out the ones which are divisible by both. Now after that we found out the one which are only divisible by d1 but not by d2. Again, we found the one which are only divisible by d1 but not d2. Similarly, we found the one which are only divisible by d2 but not d1. So this set of integers are divisible by d1. Now we subtracted the ones which are divisible by both d1 and d2. So what we remain with are the ones which are divisible by only d1. Similarly, we found out the one which are divisible by only d2 but not d1. After we found out these two, so this in this diagram, array 1 invalid would be this 9 and array 2 invalid would be this 7. Okay. Now after this, how many, like, we have to find out this 5 as well, right? What is 5? 5 are the remaining ones. So how many are remaining? We have total of x integers, right? We subtract the ones which are not divisible by anything, basically this piece. Then we subtract the one which are divisible by d1 but not d2, this piece, right? And then we subtract the one which are divisible by d2 but not d1, that is this piece. So finally we will remain with the outer piece. So that's what can be any is. Now once we have these three integers, rest are simple. What we need to do, we need to just find out, we we first need to assign this seven integers to array 1. So that's what we are doing. We are saying that, okay, how many, like, is count 1. Count 1 is the number of integers that I need to assign to array 1, right? So what we are saying is, okay, is count 1 number of integers to assign is greater than the number of integers which can only be assigned to array 1. So this array 2 invalid are the ones which can only be assigned to array 1. So we are saying that, okay, after assigning this, is there anything left? So if there is something left, then we will just subtract it from the outer boundary, like can be in any, right? So we'll just subtract the required ones from the outer boundary. Similarly, we'll say that, okay, is the number of integers that needs to be assigned to array 2 is greater than what can be assigned already. If it is, then we will just find out, okay, how many such integers are there which are not in d1, which are not in this circle, which are not in this circle, and based on that we'll just take those many from can be any. Okay, so after that we'll check, okay, is can be any is positive or not. So basically we are saying that, okay, how many are left here, like how many are left after assigning the this d1 left, after assigning this part to array 2 and this part to array 1, how many of them are left? And is the sum, like is this 4 is greater than equals is less than equals to 5 or not? So that's what, that is just a way of checking this, right? So if it is greater than 0, then it means we can assign all the, like we can assign array 1 and array 2 such that the maximum integer is this x, which is 17, right? So hope this function makes sense, right? Now for those who don't understand why this formula works, or why this formula works, uh, so basically let's assume that, okay, d1 is 2. Okay, so d1 is 2. So we need to find out how many integers are there which are divisible by d1. So for the integers which are divisible by d1 are d1, then 2d1, right? Then 3d1, and then so on and so forth, right? So these are the integers which are divisible by d1. So if you look at it, for a particular given x, for a particular given x, the number of integers which are divisible by d1 will be equal to x by d, right? So that's what we have doing. That's what we have done. Like basically the floor of x by d1. So that's what we have done. Like number of integers divisible by d1, number of integers divisible by d2. Now finally, number of integers which are divisible by both d1 and d1, d1 and d2 are the one which are divisible by the LCM of both d1 and d2. Right? So I would encourage you to think about it yourself. Like this would make sense. Now after we found out this, so remember where we come, like we come here from this x. So what was this x? If you just rewind the video, like we have started with, okay, can 1 is possible, is 2 is possible, is 3 possible, and so on and so forth, right? And finally we say that, okay, we just need to find out whether x is possible or not, and for that we write this function. Okay, so this is okay, like this is good. So what is the time complexity like for this function? Like what is the time complexity of the function? The function time complexity is order 1. We are just doing some mathematical operation, right? So is possible is order 1. But you have to iterate until x, right, to find out the exact answer. And what is the possible value of x? It can be cnt1 plus cnt2, right? So cnt1 plus cnt2 is up to 10 to the power 9. So iterating all the way to x is something which is not possible. Okay, so notice that what we are doing a linear search here. We are searching for x in linear fashion. So the first thing that should come to your mind is whether can we apply binary search or not. Okay, so let's see if we can apply binary search. So just to refresh your memory, the binary search is basically we are given a sample space and we divide the sample space into two halves, exactly two halves, and then we see, okay, can I skip, like based on some function, can I skip the left half completely or the right half completely? So there is a complete video that I recorded on binary search and ternary search. I would encourage you to watch that video. I will link the video in the video description. So basically it just says that, okay, can based on some condition, can I decide either to go left or to go right? Like, can I skip one of them completely? So in this particular problem, what we are saying is, okay, we need to find out whether x, let's say this is x. Okay, so we need to find out whether x is possible or not. Let's say answer is true, x is possible. Okay, so if the answer is true for this, does it make sense to search in the right half? Already x is true, so x plus 1 is also true. So what is x? X is basically the maximum value of array 1 and array 2. Now if we take x plus 1, we will have one more integer, right? So if we are already able to fill array 1 and array 2, and if we have one more integer, definitely we'll be able to fill array 1 and array 2, right, as well, right? So if x is true, all of this would also be true. So there is no point in searching in the right half. We can simply search in the left half for more smaller x, right? So if x is true, we can completely skip the right half. Similarly, if x is false, does it make sense to search in the left half? So basically what we are saying is, given let's say x is 5. So if there are 5 integers, I can't fill array 1 and array 2 with these 5 integers. There are more integers required, like there are some gaps which are still left. So for this still left gaps, we need more integers. So if we are not able to fill with 5 integers, we will definitely not be able to fill with 4 integers, right? And so on and so forth. So that's where we will only, like, we'll skip the left half completely and we'll only search in the right half. Okay, so hope this makes sense. So basically we can just uh, convert this linear search into a binary search, and the complexity would be reduced to log of x instead of x. Okay, and that would surely pass. So let's try to look at the code. The code is exactly similar to what we discussed. So this is the is possible function, and this is exactly similar to the pseudocode that we just saw. Exactly similar. There's nothing different here. Now this is the binary search part. We are initialized our L with 1 and R with 2 to the power 9, 2 into 10 to the power 9, and we are searching with if M is possible, if middle element is possible. If it is possible, we'll skip searching in the right half. So we'll just say that, okay, my new range is whatever L was there and R is M. And if it is not possible, we'll search in the right half, and hence we make our L2 M plus 1. So hope this makes sense. If you have any doubts in this problem, please post them in the comment section below. I will be happy to answer. If you like the video, give it a thumbs up and do subscribe to the channel if you haven't already. And I will see you in the next one. Thank you.